the night sky. My name is Robin. Tonight we're going to explore the constellation of Boötes, the herdsman. I'll talk about how to find the constellation, its bright star Arcturus, some deep sky objects, and a couple of the myths associated with Boötes. By late spring, the sun is setting around 8:30. By 9:30, and better yet 10 o'clock, it will be dark enough to observe. Facing east, this is where you'll find Boötes at 10 o'clock. Boötes has been described as looking like a kite, an ice cream cone, and a necktie, with the bright star Arcturus at the bottom of the kite and the ice cream cone, and at the neck end of the tie. To see the herdsman, the star at the tip of the kite is the forehead. The two stars at the broadest part of the kite are his shoulders, and the stars on either side of Arcturus are his legs. Finding Boötes is pretty easy. First, locate the Big Dipper. Notice how the handle of the Big Dipper has a curve or an arc to it. Now extend this curve past the handle and keep going until you reach Arcturus. If you can remember the mnemonic arc to Arcturus, you'll always be able to find Boötes. For us in the northern hemisphere, Boötes is almost a circumpolar constellation, being visible during some part of the night throughout most of the year. In summer, Boötes is high overhead shortly after dark. By autumn, he sets by mid-evening, and in winter, the best time to observe him is in the early hours before dawn. Because Boötes lies fairly close to the celestial equator, it's visible from both the northern and southern hemispheres. Here we see Arcturus and Boötes about 19 degrees north of the celestial equator. The celestial equator is the Earth's equator projected out into space. It divides the sky into northern and southern hemispheres, just like the Earth has northern and southern hemispheres. Now let's look at Boötes' brightest star, Arcturus. It's about 37 light years from Earth. And although you can't tell from this photo, Arcturus is a red giant star. It's the brightest star in Boötes, it's the third brightest star in the sky, and it's the brightest star in the northern celestial hemisphere. The name Arcturus comes from the ancient Greek and means bear watcher or guardian of the bear. Here we see how big Arcturus is compared to our sun. It has a diameter of almost 22 million miles, making it about 26 times the size of the sun. If we could put Arcturus where our sun is in the solar system, Arcturus would be much larger, but still within the orbit of Mercury. The rotational period of this star is about 2 years. It appears to be about 110 times brighter than the sun in visible wavelengths of light. However, Arcturus has a lower surface temperature than our sun. It's only 7,300 degrees Fahrenheit. That's several thousand degrees cooler than the sun. What this means is that much of the star's energy is radiated at infrared wavelengths of light as heat, and Arcturus releases 215 times more heat than our sun. This is an artist's conception of what Arcturus looks like. The star is thought to be 6 to 8.5 billion years old and is expected to end its life as a white dwarf star. Arcturus appears to be a single star, as no gravitationally bound companion has been found. And at this time, it doesn't appear that Arcturus has any planets. This star is moving at an incredible speed of 76 miles per second relative to our sun, and it's almost perpendicular to the plane of the galaxy. It will make its closest approach to the sun in about 4,000 years, when it will be only a few hundredths of a light year closer to Earth than it is today. In antiquity, Arcturus was closer to the center of the Boötes constellation. From Earth, Arcturus appears to be moving in a southerly direction, and in 500,000 years or so, it won't be visible except with a telescope. Arcturus is thought to be an old disk star due to its low metal content, and it appears to be moving with a group of 52 other stars known as the Arcturus stream. Here's a fun fact. Light from Arcturus was used to light up and open the 1933 Chicago World's Fair. It had been 40 years since the last World's Fair was held in Chicago. At the time, it was thought that Arcturus was 40 light years from Earth. Fair organizers thought using starlight that traveled for 40 years to reach Earth to light the venue would both commemorate the previous Chicago's World's Fair and would be a memorable way to open their exhibit. The original plan was to use the 40-inch refractor at Yerkes Observatory to capture the light of Arcturus with a photoelectric cell, amplify the faint current, and then transmit it to a switch control on the fairgrounds. But as with all astronomical observing projects, they couldn't be guaranteed a clear sky at the very moment they needed to see Arcturus. So 3 more observatories were enlisted, the thinking being that at least one of them would have a clear sky. The Harvard University Observatory became part of the project, and although I was not able to confirm this, their 15-inch great refractor may have been used for this project. The operation of the telescope fits the time frame. The University of Illinois Observatory also participated using their 30-inch reflector. Here we see the photoelectric photometer attached to the telescope. And the Allegheny Observatory was part of the team. Again, I could not confirm that the Fitz-Clark 13-inch refractor was the telescope used, but the timing and operation of this scope is right. Each observatory was directly connected to the fairgrounds by a Western Union telegraph line to this large panel set up in the courtyard in front of the Hall of Science. The lower half of the board contains a map showing the location of the 4 observatories and the World's Fair. The upper half of the board contained the switches that closed the circuit. One by one, each observatory was asked if they were ready. As each responded yes, a red glow ran across the map from the observatory to the fairgrounds. When the last signal was received, the switch was thrown and a white beam of light shot out across the sky. It circulated slowly from one exhibit building to another, and as it touched each one, they burst into full illumination. The Arcturus project, as it was called, was a success. It did provide a unique and memorable experience for the fairgoers, but it also put a spotlight on the new technologies being used by astronomy researchers. As we now know, Arcturus is 37 light years away, not 40. So the light used to open the 1933 fair was actually 37 years old, not 40. Now, let's move on to some of the deep sky objects. When we talk about deep sky objects in a constellation, we don't necessarily mean that the object is located within the lines marking the pattern of the constellation. The object might be within the lines, but it could be outside these lines and within the border of the constellation. The sky has been divided into 88 constellation regions. Think of it as equivalent to a state being divided into counties. Every star we see and every deep sky object lies within the border of one of these 88 constellation regions. Here we see the border of Boötes. Most of the deep sky objects in Boötes lies in the border surrounding the constellation. Let's look at NGC 5466, a globular star cluster. Globular clusters, by definition, are stars tightly bound together by gravity, giving them their symmetrical shape. All the stars form from the same cloud of gas and dust, and the resulting clusters have a very high concentration of stars at their core. They are the largest and most massive type of cluster, containing the oldest stars. And these clusters are big, really big, reaching up to 300 light years in diameter and containing hundreds of thousands of stars. NGC 5466 is a globular cluster, but it doesn't quite fit the definition. It doesn't contain hundreds of thousands of stars, and there isn't a tight clustering of stars at its center. Even its shape is a little wonky. The cluster is 12 to 13 billion years old and has a mass of only 50,000 suns. By tracing its motion back 100 million years, astronomers have determined that this globular was likely a member of another galaxy, a satellite galaxy, that was captured by the Milky Way. Its merging with the Milky Way stripped away many of its stars, and even now its stars are being pulled away in a stellar stream that gives the cluster a slightly elongated look. This NASA graphic shows 3 stellar streams, remnants of cannibalized galaxies and star clusters. Now let's look at NGC 5676 and NGC 5660. Both are spiral galaxies. These 2 galaxies belong to a group of about 20 galaxies gravitationally bound together. This part of Boötes is just littered with galaxies. Nearly every object in these photos is a galaxy. NGC 5676 is an edge-on spiral, about 112 million light-years away, and NGC 5660 is a face-on spiral 9 million light-years away. And because I like galaxies, I'm going to show you one more, NGC 5614. NGC 5614 is usually classified as a triplet system. 5614 is about 180 million light-years away. NGC 5613 is a ring-type galaxy that is about 360 million light-years away. And NGC 5615 looks like a small, diffuse knot on the edge of 5614. And is actually interacting with 5614. The faint plume coming off 5614 is evidence that the 2 are gravitationally interacting. 5614 is classified as a peculiar galaxy. It's a spiral with an inner ring and a plume. It's also called a nuclear spiral because there is a spiral structure wrapped tightly around the core. This type of structure is thought to be the telltale sign of a supermassive black hole at a galaxy center. Let's move on to some mythology and star stories. In Greek mythology, Boötes is a herdsman, followed behind and herding Ursa Major, the great bear, through the sky. As the story goes, there was once a beautiful woman named Callisto, who was turned into a bear by the goddess Hera because she had a son with Zeus. Time went by, and the boy, named Arcturus, grew into a man. One day, while Arcturus was hunting, he ran into a bear, and unknown to him, it was his mother, Callisto. Callisto tried to greet him, but Arcturus misinterpreted her movements and growls and began to chase her. Before Arcturus could kill his mother, Zeus stepped in and placed both in the sky. Callisto became Ursa Major, and Arcturus became Boötes, the bear guardian. Belarusians saw Boötes as the plowman. The Big Dipper is his plow. The Burong people of Australia saw these stars as the meat ant. In their mythology, a popular legend is that people used ants to stitch cuts together. The ant would be placed on the cut and encouraged to bite. As soon as the pincers are embedded on either side of the wound would heal. This also works to put people back together that have been torn to bits by, say, a monster. The Inuit used Arcturus and a lake star to form their constellation, 2 in front. This constellation represents a little orphan boy being chased by an angry grandfather. Arcturus has as much and maybe more mythology than Boötes. This fascination with the brightest star in the northern hemisphere continues today. And even though no planets have been found orbiting Arcturus, it hasn't stopped science fiction writers from creating them. There have been many science fiction books, book series, television shows, and movies where Arcturus as a star or a fictional planet having the same name is used. On Star Trek, Arcturus IV is a planet orbiting Arcturus and homeworld of the Arcturians. On Doctor Who, the Arcturans were a species from the planet Arcturus. In the movie Aliens, Arcturians were a species native to the planet Arcturus. In the book A Voyage to Arcturus, the star has a planet named Tormance. Isaac Asimov's Foundation book series has a planet named Arcturus, and The Hitchhiker's Guide to the Galaxy has a star Arcturus whose system is home to a lot of deadly megafauna, like the megadonkey and the megacamel. I think the star Arcturus will continue to inspire stories for a long time to come. Thank you for watching, and I hope you've enjoyed exploring Boötes with me. Join me next month when we explore the constellation of Draco the Dragon.